Good evening, all of you. This is session 8, live interaction session. So, begin with the first question. The total general nitrogen concentration in the domestic sewage is a sum of the concentrations of. So, they have mentioned the four options. The first option is organic nitrogen and inorganic nitrogen in sewage. Second option is organic nitrogen and the nitrate in sewage. Third option is organic nitrogen and the ammonia in sewage. Fourth option is ammonia and nitrate in sewage. So before beginning with the solution, I will first tell you the different forms of the nitrogen. So the the different forms of nitrogen. So nitrogen exists in different forms, such as first one is free ammonia. This is the first form. Second form is organic ammonia. Third form is nitrite, and fourth form is nitrate. So these are the four forms of nitrogen. In first case, the free ammonia basically indicates recent pollution. It indicates recent pollution, and it exists in the form of NH4 plus and NH3. Free ammonia. Organic ammonia basically indicates the quantity of nitrogen before decomposition has started. Okay, it indicates quantity of nitrogen before decomposition has started. So, okay, am I audible now? Uh, Azad Ahmed, am I audible? Okay. So this is the GATE 2015 question. I will repeat once again. This is the GATE 2015 question. So in this question, they asking the total general nitrogen concentration in the domestic sewage is the sum of the concentrations of. In the first option, they have mentioned organic nitrogen and the inorganic nitrogen sewage. Second option, they have mentioned organic nitrogen and nitrate in sewage. Third is organic nitrogen and ammonia in sewage. Fourth is ammonia and nitrate in sewage. Before solving this, I will first discuss the different forms of nitrogen. Then we will know which is the correct answer. So the different forms of nitrogen are free ammonia, organic ammonia, nitrite, and nitrate. Free ammonia basically indicates the, so these are the different forms of nitrogen. Different forms of nitrogen. So free ammonia, organic ammonia, nitrate, and nitrate. Free ammonia indicates the recent pollution. Ammonium and ammonia. Organic ammonia indicates the quantity of nitrogen before decomposition has started. So basically, this remains in the free ammonia. I am talking about free ammonia. Free ammonia remain in bonded form. Free ammonia remain in bonded form with urea and protein. Urea and protein. Okay. Now, for nitrite, nitrate indicates the partially decomposed condition. It indicates partly decomposed condition. On the other hand, nitrate indicates old pollution, means fully oxidation. It indicates old pollution. Now the question is asking the total nitrogen concentration in domestic sewage is the sum of. Basically, TKN, total general nitrogen, is the sum of TKN, total nitrogen. Always remember, total nitrogen concentration is the sum of free ammonia plus organic ammonia. So free ammonia we know now, and organic ammonia, the summation of free ammonia and organic ammonia is basically the total nitrogen. So option C is correct. I hope the first question is clear. Now we will move to the second question. The second question says, so this is a municipal solid waste question. It came in GATE 2015 and in set 1. So the solid waste generated from an industry contains only two components, X and Y, as shown in table. So X component has a composition weight is C1 and its density is rho 1. Whereas the component Y has a percentage weight composition is C2 and its weight is rho 2. So assuming C1 plus C2 is equals to 100, the composite density of the solid waste is given by. Uh, so A is this first. So we will solve now. So uh, so the so the first, based on the question, we will first write the given data C1 plus C2. C1 plus C2 is equals to 100. This is given, right? So this quantity is already, the composite density will be, we know density is equals to mass by volume. So component 1, so volume, we will find the individual volume. Volume of C1 will be, this composition is C1 mass by volume, so C1 by rho 1, because density is equals to mass by volume. So if we have to write it, it will be m by rho. I know I have some background disturbances. Some function is going on in our campus, so I cannot uh, do anything. So please bear the situation today. So the volume of C1 is C1 by rho 1. So similarly, we can write the volume of another component X. So sorry, this is the volume of X. This is volume of X. This will be volume of Y. This is the volume of X. This is the volume of Y. This is will be C2 by rho 2. I hope till now this thing is clear. So component X and Y. If we have to find the composite volume, so composite volume will be total mass, or you can write total weight divided by total volume. So total mass by weight will be, total mass will be C1 plus C2. Total volume will be, we have calculated the volume of X, C1 by rho 1, C1 by rho 1 plus C2 by rho 2. So from here we can calculate 100 by C1 by rho 1 plus C2 by rho 2. I hope this is clear. If you have any doubt, anyone has any doubt?
No, sir.
Okay. So to summarize it, see, they have given the composition percentage weight of individual component and density they have given. They have even mentioned the C1 plus C2, the composition percentage weight is equivalent to 100 summation. To find the composite density, we know that the total mass by total weight. We found the individual volumes, and using those expressions, we found the composite volume. And finally, the composite volume expression came out in this form: 100 upon C1 by rho 1 plus C2 by rho 2. So the option A is correct in this question. So now we will begin with fifth, uh, the third question. So this also came in GATE 2015 and in set 2. So question 57, a landfill is to be designed to serve a population of 2 lakh persons for a period of 25 years. The solid waste generation is 2 kg per person per day. The density of the density of uncompounded solid waste is 1000. kg per meter cube and a compaction ratio of 4 is suggested. The ratio of compacted fill, that is solid waste plus cover, to compacted solid waste is 1.5. The landfill volume in million meter cube required is. So before beginning with this question, we will first understand what is meant by the compaction ratio here. Okay, and the second thing is the landfill volume is required. So what is meant by landfill volume here? To begin with this question, the no, we should know these things. The compaction ratio here means volume of solid waste before compaction, volume of solid waste before compaction divided by volume after compaction. Volume after compaction. Okay, this is first thing. Second thing is total volume. Landfill total volume here means one is you have to calculate the volume of solid waste plus the landfill cover, because if this is the landfill, after filling the waste here, we generally provide a cover to the surface. So we are, for the total volume of the landfill will be solid waste plus cover. So these two things we have to keep in mind. Now we will solve this question. Now see, they have mentioned the solid waste is to be designed to serve a population of 2 lakh person for a period of 25 years. For a period of 25 years, the solid waste generation is 2 kg per person per day. Okay. Now from this we can calculate the solid waste generated per day. Solid waste solid waste generated per day. So this quantity will be 2 lakh into 2 kg into 2. If we multiply this population with the per capita production of solid waste, then we will get the solid waste per generation per day. So will be 2 into 2 lakh. Okay, this came out to be kg. Okay, so I am again repeating, like some background noise is there. So in our campus some function is going on. So I am really sorry for the background noise. If you have any doubt, you can please ask me. So solid waste generated per day is 4 lakh kg. So knowing this, now this is a per day. If I want to, now we have to calculate the solid waste generated in 25 years. Since the landfill is designed for a period of 25 years. Now total solid waste generated per in 25 years. Total solid waste generated 25 years will be, we will multiply the volume of waste generated per day into 365 days into 25 years. So it will be 3.65 into 10 raised to 9 kg. So this is the total solid waste that is generated in 25 years, and the compaction ratio. So now we know this is the total solid waste generated in 25 years. So the compaction ratio, now we have to use this. So compaction ratio, as I have mentioned, volume of volume before compaction and volume after compaction. So this I have mentioned, volume of solid waste before compaction and volume of solid waste after compaction. So the compaction value has been given here as 4. So this is 4 equals to volume of volume before compaction and volume after compaction. So now we have our expression in this form. but we have to calculate the volume before compaction first. So volume of before compaction, how we will calculate? Volume before compaction will be calculated as, we know density is equals to mass by volume. Here I am writing density is equals to mass by volume. To calculate the volume, it will be mass by density. Using the same concept, we just now calculated the total solid waste generated in 25 years. That is, this is the mass, 3.65 into 10 to the power 9. 3.65 into 10 to the power 9 divided by density. The question has given the density of 100 kg per meter cube of uncompacted solid waste. Since they have given the density of uncompacted solid waste, we are calculating volume of solid waste before compaction. That is by 100. So it is 3.65 into 10 raised to the power 7 meter cube. This is volume before compaction. Now, how we will calculate the volume after compaction? Using this expression. We know now the volume before compaction. So volume after compaction, what it will be? Volume after compaction is equals to volume before compaction divided by 4. Using this, we can calculate the volume after compaction. So 3.65 into 10 raised to the 7 divided by 4. So this comes out to be 9.125 into 10 to the 6 meter cube. This is the volume after compaction, this is the volume before compaction. Okay. Now we take the third statement, what it is saying. The ratio of compacted fill, solid waste plus cover, to compacted solid waste is 1.5. So now we will use this thing. So it is saying compacted solid waste plus cover to solid waste is 1.5. So we can write this expression like 1 plus cover by solid waste, which is equals to 1.5. We can solve this equation by cover by solid waste is equals to 1.5 minus 1, which is equals to 0.5. Okay. Now to calculate the cover cover volume, so 0.5 into solid waste. Solid waste we just now calculated after compaction is 9.125 into 10 to the power 6 meter cube. So cover will be 0.5 into 9.125 into 10 to the power 6 meter cube. So if we solve this, the value will come out to be 4.5625 into 10 to the power 6 meter cube. So this is the volume of cover. Volume of cover. Now, knowing the volume of cover, so total, now we know, first we calculated the volume after compaction. This we know, this is the solid waste. Now we know the volume of cover, and initially before beginning the solution, I told you total volume will be solid waste plus cover. So we have to so total volume will be now, so total volume will be volume after compaction 9.125 into 10 to the power 6, 9.125 into 10 to the power 6 plus volume of cover, that is 4.5625 into 10 to the power 6. It is 4.5625 into 10 to the power 6. So if you solve this, the total volume will come out to be 13.6875. 13.6875 meter cube. So it has a million meter cube. So it will be 13.6865 million meter cube. Okay. Anyone has any doubt, or should I explain it once again?
No, sir.
Okay. What about others? Anyone other? If anyone wants that I should repeat this because it is a bit long question, I can again explain. So, okay. So at the end, anyway, I will summarize whatever question we are solving today. Now, in another question, which also came in year 2015, so which says a wastewater treatment plant of capacity 1 meter cube per second has a filter box of dimensions 6 meter into 10 meter. Loading rate to filter is 120 meter cube per day per meter square. When this statement is very important, when two of the filters are out of for backwashing, the loading rate is now. First, they have mentioned the water treatment plant has a capacity of 1 meter cube per day, 1 meter cube per second. First, we will calculate the total water filtered in a day. So, total water filtered in a day or per day if you write total water filtered per day will be, to convert into meter cube per day, it will be 1 divided multiplied by 24 into 3600, so it will be 86400 meter cube per day. So this is the total water filtered in a day. Now now you can, the loading rate they have mentioned there 120 meter cube per day per meter square. To calculate the total surface area of the filter, total surface total surface area of filter required, total surface area of the filter required, C. You just look at the units, that is meter cube per day, and the loading rate is in meter cube per day per meter square. So to calculate the surface area we need the unit in meter square. Okay. To how we will get this unit, if we divide this total water filtered per day divided by this unit surface loading rate, we will get in terms of meter square. So 86400 divided by loading rate 120, so meter cube per day, and here meter cube per day per meter square. So this will get cut and the meter square will go in numerator. So we will get a 720 meter square, 720. Okay. Total surface area of the filter required is 720 meter square. Now area of one filter, this is the total area of surface area of the filter required. Okay. They have mentioned that the filter boxes of diameter 6 meter into 10 meter. This is the filter of area of one filter. This is the area of one filter. So area of one filter is basically, area of one filter is 10 into 60, 10 into 6. This is 60 meter square. Okay. Now we know the total filter area required and the area of one filter. Using that we can calculate the total number of filters. Total number of filter. So total number of filter is total surface area of the filter divided by the area of one filter. 720 divided by 60. So this is 12 filters. 12 filters. Okay. But in the question says that when two of the filters are out of the service for backwashing, the loading rate is, if two if two filters are if two filters are out of service, number of filters remain will be, number of filters remain the number of filters remaining will be 12 minus 2, that is 10. If two filters are out of service, 12 minus 2, 10 it will be. Okay. Now total surface area of the filter will be, since now we have a 10 filters and individual filter area is 60 meter square, the total now filter area will be, total surface area of filters will be 60 into 10. that is 600 meter square. This is a new total surface area of filter because after if two filters are out of surface, the number of filters remaining will be 2n minus 2, that is 10. Now the total surface area of the filter will be, since we know the area of individual filters and now the total number of filters are 10, we got total surface area of filter is 16 to 10, that is 600 meter square. Therefore, the new loading rate will be new new loading rate will be new loading rate will be to the how much water need to be filtered in a day, 8640 meter cube per day, 86400 meter cube per day divided by, just now we calculated that area, total surface area of the filter, that is 600 meter square. So the value will come out to be 144 meter cube per day per meter square. Just be careful about the units. It is in meter cube per day per meter square, since they have asked us about the loading rate. So the new loading rate is meter cube per day per meter square will be 144 meter cube per day per meter square. This is the answer. So is anyone have any doubt?
सर रिपीट करना प्लीज.
What?
सर प्लीज रिपीट दिस क्वेश्चन.
Okay. So see, initially they are telling a wastewater treatment plant has a capacity of 1 meter cube per second. Okay, and has a filter boxes of dimension 6 meter into 10 meter. These are filter boxes dimension, individual filter boxes. The loading rate to the filters is 120 meter cube per day per meter square. Okay, then they are telling what will be the loading rate when two filters are out of service for the backwashing. Okay, now they are telling, they have, like in the question they are mentioning that the this much treatment capacity they have in the plant, and the individual dimensions they have mentioned, the loading rate to the filters also they have mentioned. So this is the initial loading. Now they are telling if the two filters are out of service for backwashing, then what will be the new loading rate? To know the new loading rate, I should know first how many total filters are there at present. So using the given data, first I calculated total water filtered in a day. So when I calculated total water filtered in a day, I got 8640 meter cube per day. I simply converted this 1 meter cube per second into meter cube per day. Okay. Now I will calculate the total surface area of the filter required. So total surface area, since they have mentioned the loading rate, so if I divide it, I will get the 720 meter square is the total surface area of the filter required. I calculated the total surface area of the filter required because they have mentioned the dimension of individual filters. So when the total surface area of all the filters divided by the like the individual dimension of the filter, if I divide, I will get the area of one filter. I will get the total number of filters. So total number of filters. This is see, surface area of the filter is came out to 720 meter square. Area of individual filter is 60 meter square. So I got the total number of filters, that is 12 filters. Now the question says what if the two filters are out of service, then what will be the new loading rate? If two filters are out of service, obviously the number of filters which will be functional at that time will be 12 minus 2, that is 10. Now for the number of 10 filters, I should know the total surface area of the filters. So 60, I know the individual area of one filter. Now total 10 filters are there. So total surface area of the filters will be 600 meter square, 60 into 10. New loading rate. Now new loading rate will be the total treatment capacity which the plant has divided by the total surface area of the filters after removing the two filters. So if we divide by 86400 by 600, this is the total surface area of filters after considering considering two filters are out of service. Two filters are out of service. So new loading rate will be 144 meter cube per day per meter square. Is it clear now?
Yes, sir.
Okay. Anyone, any other student has any doubt? What about others?
No, sir.
Okay. Now we'll proceed to the next question. This question also came in GATE 2015 in set 2. So the question says, so the ultimate BOD of a river water sample is 20 milligram per liter. Ultimate BOD. The BOD rate constant is 0.15 per day. The respective values of BOD in percentage exerted and remaining after 7 days will be. See, they didn't ask what will be the BOD exerted or remaining. They have asked in percentage. So percentage, how we will calculate? At movement, what will be the BOD divided by the initial BOD? Like total, what will the ultimate BOD basically? So for percentage calculation, this will be our approach. We will first calculate the BOD of that thing, like what is the BOD exerted and what is the BOD remaining. Then we will divide by the ultimate BOD to get the percentage. So the approach, our approach should be, so the first I will calculate the BOD remaining after 7 days. BOD BOD remaining after 7 days will be BOD ultimate e raised to minus kt. You can write as L naught e raised to minus kt. That is LT is equals to e raised to minus kt. Okay, LT means BOD remaining after 7 days. So if we put the ultimate BOD value, that is 20 milligram per liter, and E, the K value is 0.15 into T. T is 7 days. So our value will be come out to be 20 into 0.35. This is the BOD remaining after 7 days. But now we have to calculate the percentage of the BOD remaining. In percentage, if we calculate, in percentage it will be 20 into 0.35 divided by the ultimate BOD. Ultimate BOD is 20 into 100, which is equivalent to 35%. Okay, this is the percentage of the BOD remaining after 7 days. Percentage BOD remaining after 7 days. Okay, in percentage, this is in percentage if we say. Now this one part is over. We got 35%. For the second part, like what is the BOD exerted? So we will calculate BOD exerted in 7 days. BOD exerted in 7 days will be BOD ultimate minus, see, this much is remaining 35%. So 0.35 into BOD ultimate. Exerted means this is the initial amount remaining. In between this, that will be the exerted. Now BOD ultimate is 20 minus 0.35 into 20. So you can write it as 0.65 into 20. Okay. Now to get in percentage form. In percentage form. So what we will do, BOD exerted in 7 days is 0.65 into 20. Okay. Divided by ultimate BOD. So into 100. So we will get as 65%. See, that is the initially we calculated the BOD remaining. Now we are calculating the BOD exerted. We have to very carefully observe the words used in the question. This is exerted and this is remaining. So our answer is BOD exerted is 65%, BOD remaining is 35%. So option C is correct. Is this question is clear? Huh? Anyone has anything to ask?
Sir, what is exerted BOD?
See the question. Okay. The exerted BOD means biological oxygen demand which has been met in between the days. Initially, now see, suppose initially biological oxygen demand is this much at a point. So if I talk in terms of graph, this is the time t days. So this is the initial biological oxygen demand. Now after time t, our biological oxygen demand is this much. The graph will be there, right? In between this point to this point, so we call it BOD exerted. Okay, and at this point we
Okay,
call
sir.
it a BOD at time t, BOD remaining. Okay.
Okay, sir.
Now, thus 2015. This is another question, which is also on 2015. So, in wastewater treatment plant, the primary sedimentation tank designed at an overflow rate of 32.5 meter cube per day per meter square. Yes, 32.5 meter long, 8 meter wide, and liquid depth of 2.25 meters. If the length of the weir is 75 meter, the weir loading rate is. So the weir loading rate they are asking. So first we will write down the data which they have mentioned in the question. Overflow rate. Overflow rate is 32.5 meter cube per day per meter square. From the past classes we know overflow rate is Q by BL, which is 32.5 meter cube per day per meter square. From here we know the value of B and L. B they have measured 8.48 meter wide and L is 32.5 meter long. So Q is 32.5 into 32.5 into 8. So Q we will get as 8450 meter cube per day. Okay, this is the flow rate meter cube per day. Now we will calculate the weir length is given as 75 meters. Now we will calculate the weir loading rate which they have asked in the question. So weir loading rate, from the unit you can see, if we divide the flow rate by the length of the weir, we will get the weir loading rate. So weir loading rate, weir loading rate is this flow rate by weir length. So discharge we know 8450 meter cube per day, and divided by weir loading rate, in the question they have mentioned 75 meter. So this is 112.66 meter cube per day per meter. Okay. So this was the question. They have asked about the weir loading rate. For weir loading rate, we should know the flow rate. If we divided the flow rate by the weir length, we will get the weir loading rate. Initially, with this expression, we calculated the flow rate Q 8450 meter cube per day, and for weir loading rate is Q by weir length. Weir length is given in the question. We calculate the 8450 meter cube per day, and by 75 meter we got 112. This is 112.66 meter cube per day per meter. I hope the last question is clear. Anyone has any doubt here?
Yes, sir.
Okay. So now I will summarize the entire session of today's class. So the first question we solved about that the what is total general nitrogen. So in this I explained the different forms of nitrogen where I mentioned free ammonia basically means recent pollution and free ammonia exists in the form of ammonia and ammonia. Organic ammonia indicates the quantity of nitrogen before decomposition has started and this organic ammonia remains in the bonded form with urea and protein. Nitrite basically indicates the partly decomposed condition and nitrate indicates the old pollution. These are the four different forms of nitrogen. And as per the question, total general nitrogen domestic is the sum of the total general nitrogen concentration is the sum of free ammonia and the organic ammonia. Okay, remember this. Okay, now second question we solved where the question has given the different components and the composition and the density and they have asked us to calculate the composite density. Composite density basically means the total mass by total volume. Total mass they have given as 100 and the individual volume we have calculated. Individual component volume we have calculated and if the we write like this we will get this kind of expression. Okay, in this option A is correct. Now this question 2015. Now this in this the landfill they have mentioned they have to serve a certain amount of population that is 2 lakh for a period of 25 years and they have mentioned that the solid waste generation is 2 kg per person per day and in this they have mentioned the density of uncompacted solid waste is 100 kg per meter cube and a compaction ratio of 4 is suggested. Now they have mentioned the ratio of compacted fill that is solid waste plus cover to compacted solid waste 1.5. The landfill volume in million meter cube required is. So here we should know the two concepts what is compaction ratio volume before compaction volume after compaction. So this is the compaction ratio and this is the total volume that is solid waste plus cover. Since total volume of the solid waste is solid waste plus cover, so we proceeded with solid waste generated per day. Then we calculated the solid waste generated in 25 years. So after knowing these things, we use the compaction factor, compaction ratio basically. So compaction ratio says volume before compaction divided by volume after compaction. But compaction ratio they have mentioned as 4. So volume before compaction we can easily calculate using density is equals to mass by volume because they have mentioned the density of the uncompacted waste. So here see the density of uncompacted. Since they have mentioned the density of uncompacted waste, we can calculate the volume before compaction using this density. So density is equals to mass by volume, where volume we can write as mass by density. Same mass we calculated for 25 years is this much and density is this 100. We got the volume before compaction. Now in this unit we know the compaction ratio, we know the volume before compaction, we can easily calculate the volume after compaction. This expression will, if we move this here and this here, the expression will come in this form. Now we will similarly calculate the volume after compaction. Knowing the volume after compaction, we will use this data solid waste plus cover. See, these things they have mentioned in the question itself. The ratio of compacted fill, that is solid waste plus cover, to compacted solid waste is 1.5. So we can write this line in this equation form: solid waste plus cover by solid waste is equals to 1.5. So if you write this as individual way, solid waste plus cover by solid waste, this will come out to be 1. Okay, now this we can write like this: 1 plus cover by solid waste is equals to 1.5. This, using this we calculated the volume of cover. Now we know the volume of cover, we know the volume of solid waste. So total landfill volume will be, as question says, the landfill volume is required is the total landfill volume required will be total cover and total solid waste generated. Okay, they come out with 13.6875 million meter cube. This was our third question. This was our fourth question where they are asking BOD exerted and BOD remaining. We first calculated the BOD remaining, then we subtracted for calculating the BOD exerted. Okay. So for percentage form, we have to divide by BOD ultimate. In the last question, they are asking the wear loading rate. Always remember the wear loading rate basically means flow rate loading rate, the flow rate divided by the wear length. So Q we have to calculate. We calculated the Q using the overflow rate equation. Since the overflow rate data they have mentioned as 32.5 meter cube per day per meter square, we know overflow rate is equals to Q upon BL. So Q is equals to this much quantity. So wear loading rate, we so Q bar upon wear length, we place the appropriate data in the respect equations, and we got this as a wear loading rate. I hope today's session was clear.
Yes, sir.
Okay, and if any one of you want me to discuss some other topics, so you can tell me also in the next class whatever topics you want that I should cover. You can give your preference also. Okay, so this is all for today. I will be here till 7 o'clock. If anyone has any doubt, you can ask me. Yeah, welcome, Gurbinder. Book. What you want to know? Book. Sagar Jadhav. Which book we can refer for this EE subject? Uh, see, uh, I will suggest for. I generally Metcalf Eddy is very good. Metcalf and Eddy. If you read this book, this is very knowledge good book. It will give you lots of information. So Metcalf Eddy or SK Garg also you can follow. Any other thing? Yeah, welcome. So if you have any doubt, you can stay. Else, you can please leave.